Hello everyone and welcome to another session of Learning Mathematics Conceptually with Mrs. Bensley. Today we will be looking at algebraic substitution. By the end of today's video, you should be able to explain the concept of substitution as it relates to mathematics, solve simple expressions using substitution, and appreciate the use of algebraic substitution in real life. To start this video, we're going to ask a quick question. So during a football match, one of the players got injured and was unable to play in the final half of the game. So explain what you think the coach will have to do in this situation. That is correct. So he will most definitely have to replace the injured player with an healthy player, someone who is able to effectively finish the game and play the game. In other words, he will need to do a substitution. So he will need to substitute another player for the one that is injured. In a nutshell, another word for substitution is to replace. Substitution means to replace. It means that we replace one value for another value. In algebra, since we're dealing with variable, it means that we will substitute a constant or use a constant to replace the variable. If we start with the expression 2x plus 5, we want to solve when x is equal to 3. So we're going to substitute 3 or use 3 to replace x in the initial equation. So we will end up with 3 plus 5. Now we can solve. So 3 plus 5 will give us 8. Let's look at another example. Let's look at 8 plus y. We want to solve this when y is equal to 6. So we're going to substitute 6 for y. Let's go. So it's 8 plus 6. And when we solve this, we are going to get 14. Pretty easy. But let's look at another one that may be a little bit more difficult. Let's look at 2x minus 1. And we're going to solve when x equals 4. To do this, we need to recall what 2x means. 2x literally means 2 times x. So if we're going to replace x for 4 or 4 for x, we're going to end up with 2x, which is 2 times 4 minus 1. And this we can simply go ahead and simplify, and we will end up with 2 times 4, which is 8, minus 1, which gives us a total value or a final answer of 7. If we recall 2, instead of writing 2 times 4, we could replace the x with 4 and put the 4 in brackets. So we would write 2 open bracket 4 close bracket. It means the same thing as 2 times x. It also means to multiply. So let's go. So we would write 2 open bracket 4 close bracket minus 1, which means 2 times 4 minus 1, which is 8 minus 1 or 7. Let's look at another example. Alright, so let's look at another example. Let's look at 3a plus 3. And we're solving when a equals negative 2. If we substitute our value for a, we end up with 3 times negative 2 plus 3, or we can always represent this as 3 open bracket negative 2 plus 3. We're going to need to solve this problem. But before we do, let's quickly recall the product of a positive and a negative number will always be negative. So if we multiply 3 times negative 2, our answer must be negative 6. So that is negative 6 plus 3. Negative 6 plus 3 will give us negative 3. Why? We subtract the smaller number from the larger number and keep the sign of the larger number. So our answer should be negative 3. 5a squared minus 2 when a equals negative 2. In this example, we are actually going to solve using exponents. So we substitute negative 2 into our original equation. But if we look carefully, we see that we have 5 minus 2 squared. So we're going to use BIMDAS, or we're going to use order of operation to solve this problem. So the first thing that we need to do is to solve our indices or exponents. Let's recall. Negative 2 means negative 2 times negative 2. And if we recall, the product of a negative number and a negative number will always be positive. Therefore, we are supposed to end up with 5 times 4 minus 2, which will give us 20 minus 2 equals 18. So whenever we are substituting values, we are always going to recall our basic rules for computations. And if we have brackets in our problems, if we have exponents, we are going to need to obey our basic operation rules. Let's try a more complex question. This says negative 3b squared plus 4b minus 2. In this question or problem, we have b being represented twice. It means that whatever the value of b, we are going to need to put it everywhere b is. So we are substituting or replacing b, with 3, since we're solving when b equals 3. So everywhere b is, we're going to ensure that we put our 3 and we simplify. So we are going to have negative 3 times 3 squared plus 4 times 3 minus 2. When we simplify our exponents, we end up with negative 3 times 9 plus 4 times 3 minus 2, which will give us negative 27 plus 12 minus 2. If we recall, when we're adding and subtracting, if the signs are different, then we subtract the smaller number from the larger number and keep the sign of the larger number. So we have negative 27 plus 12. So we're going to subtract 12 from 27 and keep the sign of the 27, which is a negative sign. We're going to end up with negative 15 minus 2. Again, if the signs are the same, then we add the numbers and keep the original sign. So we're going to end up with negative 15 minus 2 being 17, and since the sign that we have been using is negative, our answer is negative 17. Again, we're going to be ensuring that we do not forget what we have learned when we were doing directed numbers or exponents. So we should not be forgetting our basic operation rules. We should not be forgetting to apply BIMDAS when we're doing our problems. So we're using all of that information when we are solving our algebraic problems via substitution. Let's look at this example. 2a plus b. And we want to solve when a equals 2 and b equals negative 1. For the questions that we were doing previously, we only add one variable. Now we have two variables, and each variable has a different value. It represents a different value. It's the same procedure. We're going to use the given value or values to replace the variables. So wherever we see a, we're going to put 2, and where we see b, we're going to put negative 1. So we end up with 2 times 2 plus negative 1, which is going to give us 4 minus 1, which is 3. So we're looking at another problem. We're looking at negative 5q minus p, and we're solving when q equals 3 and b equals 4. Sorry, that b is supposed to be a p, and p equals 4. So let's go. Of course, we're going to rewrite the equation, our expression, and we are going to substitute our values where they're supposed to go. Now we have 15 minus 4. 15 minus 4 is 11. So whether it is that we have one variable or two variables, the steps remain the same. We're going to substitute the given values for the variables and solve. All right, so let's look at another problem. Let's look at x halves plus 4y. And we're solving when x equals 10 and y equals 2. Sometimes when we see fractions, we get a little bit timid, but it is the same procedure. All we're going to do is to substitute our values. If we recall, the fraction line in a fraction means to divide. So basically, 10 halves is the same thing as 10 divided by 2, which is 5. So we can simplify this expression to become 5 plus 8. From this, it's pretty straightforward. 5 plus 8 gives us 13. With that being said, let's try a few activities. Let's substitute these values into these expressions, where x equals 4 and y equals 7, z equals 2. So let's give you a few seconds to attempt the question. If you need additional time, you can pause the video and then continue. All right, so we have x plus y plus z. We're substituting our values and we should get 4 plus 7 plus 2. From here, we can simplify, we get 13. The second one is 2x minus y plus 3z. If we go ahead and substitute our values, we end up with 2 times 3 minus 7 plus 3 times 2, which is 6 minus 7, which when further simplified is 12 minus 7, which gives us a total of 5. So let's look at another few questions. So we're going to substitute this value in the expression. So m is going to be negative 2, n is 4, p is 3, and q is going to be 8. 3m minus 2q. If we go ahead and substitute, we end up with 3 times negative 2 minus 2 times negative 8, which should give us negative 6, negative 8 times negative 2 is positive 16, a total of 10. For our second question, m squared plus 4p plus plus q is going to give us negative 2 squared plus 4 times 3 minus 8, or 4 plus 12 minus 8, which is 8. Let's look at a real-life application problem. A customer's JPS bill is generated as such, where the first 100 kilowatts is calculated as $8.31, and for all the others after 100 it's calculated at $23.86. To solve this problem, we need to find the formula for finding the person's bill in terms of x and y. We first need to define our terms, and so for the first 100 kWh, we're going to let that equal a, and after that whatever follows is going to be b. Then the total bill would be 8.31a plus 23.86b. If we want to solve when Mr. Adams used 123 kWh, then we would want to use the same formula, and we find out 100 plus 23 gives us 123. because that's the amount of kilowatt that he used. So now we are going to substitute our value. Remember our formula. So we're going to put 100 where A is and substitute 23 where B is. Once we do that, we expand our brackets to multiply, and we end up with our answer being $1,379.78. So that's it for today's video. I hope that this video would have helped you to better understand the concepts and the steps, the procedures as it relates to solving algebraic expression using substitution. Now I'll see you at our next video. Have a wonderful one. Bye now.